Hi, this is John Carney, product engineer at Cadence, and I'm going to be talking about the Fanout command in OrCAD X. The Fanout command is accessed from this command toolbar right here. We put it under with Add Connect and Fanout. When you launch the Fanout command, you're given a couple of choices of different types of fanouts that you can add. You can do a radial fanout, which is commonly used for a BGA. Linear, which is commonly used for these types of devices here, where you can have different pins going in, out, or a stagger pattern. You can also use these for just 2-pin surface mount devices if you want. And then there's also an option for via and pad. All of these commands have the same type of parameters where you can specify the trace width for the fanout to be driven by the constraint set, or you can manually type in a specific value that you want. And then you can also specify the spacing between the pin and the via. Or in these linear fanout options, you have a couple more controls, whereas you have the trace width, which is the width of that trace there. And then you have the channel space, which is the distance between the vias that it'll put when fanning out pins all in a line. And then you also have the pin to via space. So this is kind of basically saying how big is this routing channel between this via and this via. And you have those controls on all these linear fanouts. And then of course the via and pad, it's just basically how big of a via do you want to plunk into that particular pad there. All right, so let's go into some different use models here. For radial, this kind of interactive control right here is basically going to say it's going to do a quadrant style fan out. Northeast, northwest, southeast, southwest, in all those different particular directions. Or if you wanted to, you could just individually pick one direction if you want. These fan out commands will operate based upon what you have in your selection filter. So if you want to fan out a whole entire component, you can then have components in your selection filter and then just select a component or select another component and it'll fan the whole component out. Now, if you want to only work on pins, then you could turn off components in the selection filter and then just window select around a group of pins. That way, you could do that and then select the pins, and then you only get those operating on. Or if you were to, for example, go to linear and do out, and you only have pins in the selection filter, you can select those pins and then you only get those pins. Or if you go back to components and select the component, then you get the whole component. So back to radial. I'm just going to do some undos here to get back to where I have no fan outs going on. So to take note of what this trace width is going to do for you, again, if I select this whole component, you'll notice the different trace widths that you got from the Fanout command, right? You have all your power and grounds have really thick trace widths, and all of the, let's turn every object on so I get that trace width there. All the other trace widths got a width of 2, whereas this got a width of 0.5, okay? So that's what that parameter means where it's driven by the constraint. Whereas if you really explicitly wanted everything to be 0.3, for example, you could do that and then fan out this component, and then everything's going to be exactly the same. Notice that you don't have to remove the fan out to adjust the fan out, right? So right now everything's fanned out with a 0.3. If you change that back to constraint and re-fan out the component, it pretty well redoes the entire fan out. It doesn't keep the existing fan out in place. You can lock those existing fan outs if you don't want to do it, but generally you can kind of think of this as a remove or replace the entire fan out on the selected set of objects based upon the new parameters. You also have control over which via to include in the fan out, which again is also driven by the constraint. So you can use the net default, or you can explicitly pick a different via if you want. Since I'm talking a lot about constraints, let's get into the constraint manager and show you what I mean by this. For any type of net in the constraint manager, you're going to have a constraint set that's going to have a minimum line width associated with it. So this is where I was getting the value of the 0.2 for all those, whereas if you were to find your power and grounds in here, right, so all your power nets have a line width of 0.5, and those are driven from a physical constraint set called power. So the way you would normally work with the constraint manager is to slightly take a different direction here to talk about constraints. Is you would generally create a constraint set. So for example, here's a constraint set called power. You apply all the constraints that you want to that constraint set, and then you apply that constraint set to multiple nets, and then those inherit all those constraints. Same thing for vias. One of the constraints for the constraint sets is to tell it which via you want to use for the different nets. So constraint-driven design, set up your rules first, then use those rules in all the applications, and then you'll get the desired results. Okay, so back to linear, right? Couple examples. So you have inward, right? That's going to go inwards, out, or you can do in, out, which is going to alternate them. Or if you want to do via and pad, back to this BGA right here, select that BGA, and then you're just going to get via and pad. Another thing that you can do is, of course, you're probably going to want to provide the same kind of fan out pattern to similar devices all over the board. So you can do multi-select from this as well. For example, if you were to go back into linear and out, you can window select, and then I'm holding my, actually it already did all of them. You can see I'm going to turn off the reference designators and do that again here. Let's go into visibility. Let's turn off these reference designators. And then now you can see a little bit better what's going on. So window select, and then control, and then pick the devices, and then you get the fan out for all of those as well. Another way you can work with this is, let's say you wanted all of a particular device to be fanned out the same way. I'm going to select one device here, and it tells me it's this particular part number. I'm going to click the part number, and now the search table is populated with all of those part numbers in the design. So then you can go back to the Fanout command, and you can select all of those part numbers that you've just found. Put this over here. Okay, so select all the part numbers and select on canvas. Now you have all those part numbers selected. They're grouped together right here because they haven't been placed yet, but these could be all over the design. Then you can activate the Fanout command and then select the selection set, and you'll get all the parts that are selected. If you hold your control key and select one, it's only going to operate on that one, or deselect it from the selection set. So it really depends on what you have. If you drive the selection set from the search panel, then everything's selected, and then you can change your fan out parameters. So I'll change those to in, and just single left click on the selection set, and then you get the fan out parameters on those selection sets. All right, so let's get rid of that for a second. And then finally, let's talk about constraint regions. For this example, I have this constraint region right here. I'm going to move that constraint region down here so it kind of covers a little bit of both parts. Normally you wouldn't really do this in a design, but this is going to illustrate how constraint regions work with respect to the fan out. So the constraint region is basically saying inside this region, the line widths need to be a lot smaller. And so if we go back to radial fan out, and even though we have the trace width set to constraint, if we were to fan out this component here, I got to turn back on the reference designators on the assembly top. There we go. So I'm going to select that component, and now notice what happened here. The pins that are inside that constraint region have the skinnier trace width driven by the constraint region. The ones outside the constraint region have the normal trace width. If I were to fan out this component up here again, right? Notice you get the trace width is driven by the constraint region. Normally in a design, you would draw, the constraint regions would be right on top of the BGA. You could even build those constraint regions into your BGA footprint. And then those constraint regions would move around the design when you move the BGA component. Adding constraint regions is pretty easy. If you do want to add it at the design level, right, you can say the shape use is a constraint region. You can pick which layer the constraint region exists on, all layers, inner layers, outer layers, and then you can pick the rule set. So you have a constraint set called BGA, and you can put as many of those in the design as you want, and they're all going to follow the same rule set. So back to the constraint manager, under physical constraint sets, you also are going to have a category called region. You can think of regions as just a small little area on the PCB that has a name. So here you have any named region called BGA. Inside that region, the line width is 0.1. So you can draw this BGA region wherever you want in the design.